Hello and welcome back to the series Pyspark for SQL Developers, where we explore how to use Pyspark to perform data analysis and manipulation tasks that are common in SQL. In the previous video, we learned how to perform joins in the Pyspark and SQL Server and compare similarities and difference between them. In this video, we will focus on the Pyspark statistical functions and how they compare with the equivalent functions in the SQL Server. Statistical functions are useful for computing descriptive statistics such as standard deviations, correlation, and so on. They can help us understand the distribution, variability, and relationship of our data. We will also learn how to use the summary method to get a quick overview of the statistic of the data frame. Finally, we will compare the syntax and output of the Pyspark statistical functions with the corresponding functions in SQL Server and highlight and similarities and difference between them. By the end of this video, you will have a better understanding of how to use Pyspark statistical functions and how they related to SQL Server functions. You will also be able to apply these functions to your own data and gain insight from them. I divide the screen into two parts. On the left side, I use SQL Server Management for writing SQL queries, and right side, I use Jupyter Notebook for writing Pyspark code. First of all, I import some libraries and objects that we need for performing different statistical functions. Here we go. Import find Pyspark, find Pyspark that init from Pyspark that SQL that function import asterisk from Pyspark .SQL import Pyspark session. Oh, sorry. Okay, and okay, this line imports the Pyspark module, which is a Python library that helps you find and use the Spark in your system. Pyspark in it. This line initializes the Pyspark module, which set the Spark home environment variable and adds Pyspark to sys.path. And this line imports all the functions from the Pyspark SQL function module, which provides various built-in functions for working with a Spark data frame and column. And this line imports the Spark session class from the Pyspark SQL modules, which is the entry point to programming Spark with the dataset and data from API. Okay, Spark session dot builder. Okay, that master local asterisk dot app name Pyspark for SQL Developers statistical functions dot config Pyspark dot driver dot memory and 6G dot config Pyspark dot executor dot memory 6G that get or create. And this block, first line, this line creates a Spark session builder object which provides a fluent interface for constructing a Spark session. Master, this line sets the master URL to local asterisk, which means to run locally with as many worker threads as logical cores on your machine. App name, this line sets the application name to Pyspark for SQL Developers blah blah blah, which will be shown in the Spark Web UI. Spark driver memory, set the driver memory config to 6 GB, which means to allocate 6 GB of memory for the driver process. And Spark executor memory, this line set the executor memory config to 6G, which means to allocate 6 GB memory per executor process. And last line gets an existing Spark session, or if there are no existing one, creates a new one based on the option set in this builder. Okay. The standard deviation. The standard deviation function is a statistical function that estimates a standard deviation of sample of data. Standard deviation is a measure of how much the values in the data vary from mean of the data. A low standard deviation means that the data is more consistent of less spread out, while a high standard deviation means that the data is more variable and more disparate. The standard deviation function can be useful in many real-world scenarios where you want to analyze the variability of uncertainty of set of the data. For example, you can use standard deviation functions to measure the variability of risk of an investment or portfolio, and compare the performance or quality of different groups or product, evaluate the accuracy and reliability of a measurement or a test. Back to the code and start with SQL Server. First of all, create temporary table called df and insert some sample data to df table. Okay, and here select name as point as a std points from df group by name. Okay. The result of this code is a table with two columns, name and std points, and one row for each distinct name value in the df table. The std points column will contain the standard deviation points for each name group, this shows that Alice has a lower standard deviation and Bob and Carol, which means her points are more consistent and less variable than theirs. Okay, and equivalent code in Pyspark. Define data frame with the same data. Okay, and here, sorry. Okay. Here df dot group by name, like here. Call dot aggregate std dev. Okay, and call dot point that alias and std points, and finally dot show. Okay, you can see same result in Pyspark. The variance function is a statistical concept that can be used to find the average of a square difference between the values of a set data and their mean. The variance functions tell you how much the data varies of a spread around the mean. A low variance means that data is more consistent and close to mean, while a high variance means that data is more diverse and far from the mean. The variance function can be useful in many real-world scenarios where you want to measure or compare the variability of distribution of a set of data. For example, you can use variance function to analyze the performance or quality of different products or services, evaluate the risk of volatility of an investment or portfolio, and estimate the accuracy or precision of a measurement or experiment. Back to the code. Okay. First of all, I create a table with a 2-column product name and review score. And here drop table df. Okay, and insert some sample data. Okay, and here select from df product name and AVG. Review score and as AVG rating, and finally var review. And finally group by product name and order by AVG. Okay, here. Okay. The result of code is a table with 3 columns: product name, AVG rating, and var rating, and 1 rows for each distinct product name value in the table. The average rating column will contain the average review score for each product, while the var rating column will contain the values of review score for each product. This result set, oh sorry, I must add as var rating. Okay, this result set. This shows that Samsung Galaxy S21 has an average rating 4.5, while AirPods Pro has the lowest average rating 2.5. It also shows that iPhone 14 Pro has the highest variance 1.23, while Samsung Galaxy S21 and Kindle Paperwhite have the lowest variance with a 0.25. That means that iPhone 14 Pro has more variability and dispersion in its rating than Samsung Galaxy S21 and Kindle Paperwhite. Okay, and back to Pyspark. First of all, I create DataFrame with the same data, and here df dot group by code. Okay, product name. Okay, like here. Dot g aggregate avg call review score that alias avg rating variance call review score. Okay, review score, and that alias var rating and order by call and avg rating dot desk dot show. Okay, you can see same result, and okay. First we group by and average function, define alias name, and call the variance function, and assign alias name to this new column, and perform order by based on average rating column. The correlation function is a statistical concept that be used to measure the strength and direction of the linear relationship to variable. The correlation function can range from -1 to 1, where minus indicates a perfect negative correlation, 0 indicates no correlation, and 1 indicates a perfect positive correlation. The correlation function can be useful in many real-world scenarios where you want to explore or test the association between two variables. For example, you can see the correlation function to investigate the relationship between smoking and lung cancer. examine the relationship between height and weight, study relationship between coffee consumption and intelligence. Back to the code. First of all, create a table in SQL Server called df and insert the data into the table. Okay, I'm going to calculate the correlation based on the data from this table called df that contains 5 columns: title, genre, revenue, rating, and year. Okay, and correlation is not built-in function in SQL Server, so we must write for each custom code. Okay. Okay, the query inside the CTE select 4-column the table df, which contains information about some movies such as their title, genre, revenue, rating, and year. Genre is the genre of the movie, such as action, adventure, animation, family, and etc. And year is the year of movies release, and here average rating, the average rating of movie for each genre and year combination calculated by using the average function on the rating column. The average function returns the arithmetic mean of the set of values. Okay, and this column. Correlation rating revenue is the correlation coefficient between the rating and revenue of movies for each genre and year combination. The Pearson measured the linear relationship between variable, the ranging from -1 and to +1, where the -1 means perfect negative correlation, and 0 means no correlation, and 1 means a perfect positive correlation. The subquery use the where clause. Okay, the where clause to filter rows from the df that match the current genre and year values from the outer query, and the subquery also uses the alias name for the column name. And city group, the city groups the rows from the df by genre and year. Here, using the group by clause, this means that for each unique combination of the genre and year values, there will of no row in the CTE with the corresponding average rating and correlation coefficient values. The final query select all columns from the CTE and orders by year in ascending order using the order clause. This means that the rows in the result set be sorted by a year from lowest to highest. The final query also uses the select asterisk syntax to select all columns from the city without listing them individually. Okay, and this is for this correlation function formula. Okay, and the output. The output shows that for the genre animation family in 2010, the average rating is 7.0, and the correlation between rating and revenue is 1.0. This means that are two movies in this genre and year, Toy Story 3 and Shrek Forever After, and have them same rating of the 7.4 and very similar revenue respectively. Therefore, the rating and revenue are perfectly positively correlated for this genre and year. Another example is adventure fantasy. Okay, adventure fantasy in 99 year. Okay, where the average rating is 6.7 and the correlation between rating and revenue is minus 0.9. That means that are three movies in this genre and year: Harry Potter and Half-Blood Prince and Solomon Kane and Slumberland, and the different rating of 7.4, 6.1 and 6.7 respectively, are different revenue respectively. Therefore, the rating and revenue are almost perfectly positive correlated for this genre and year. Okay, and Pyspark. First of all, define the schema of table. And create a list of rows with data, same as okay, and same as SQL table, and then create a data frame with this schema type, this schema, and these data rows. Okay, and df dot group by call genre okay, and call year that aggregate average cool rating that alias and average rating. Okay, and okay, average. Okay, average rating, correlation, rating, and correlation column, and revenue, and that alias, and alias name, core rating, revenue, and okay, dot order by call year, based on the order by based on the year, and that show. Okay, group by DataFrame, combination genre and year, and perform aggregate average based on the rating, and define alias name for this column, and for correlation add two parameter. First is the rating and second is the revenue, and alias name for correlation column, and perform order by based on the year. Okay, and it's same as SQL Server result.